Good morning all. Welcome to my video lecture on the topic serializability from database management system. Myself Ruba Sudha, working as Assistant Professor, Department of Computer Science and Engineering in SA Engineering College, Chennai. This lecture is about gate coaching on the topic database. Okay, here I am going to explain about serializability, which comes under transaction and concurrency control. And then these are the topics today I am going to cover. Let's see one by one. So first is transaction. So generally your set of instructions, we are going to call it in programming languages program. Your set of instruction called program in programming languages like C, C++, Java. Likewise in operating system, your set of instructions we are going to call it as job, thread or process. Likewise in database management system, your set of instructions we are going to call it as transactions. Here in transaction we are having many operations in your transaction. One is read operation, another one is write operation. So let's see one by one. So first is your read operation. So here your read operation is nothing but read operation reads the data from the database and then it stores in the buffer in the main memory. Let's consider the example read of A. So your read of A, your instruction, here it will request the data from the database. So from the database, this is your database, it requests data from the database and then it reads the data from the database and store it in the main memory. Inside main memory we are having a buffer, so in that buffer it will store the data. Okay, whenever it will perform operation, it fetch the data from the buffer and it process the data. After completing processing, we need to update this data into the database. That is your write operation. After performing any operation, we need to update the value back into the database. Okay, here this is your database. From that buffer we are going to store the value. So your write operation is nothing but we are going to update the data value back to your database. This is your write operation. And then next is your transaction state. Your transaction state, for each and every transaction there is a different states for this. So in transaction states, each transaction comes under different states throughout its life cycle. So here these are your different states of your transaction. Your first state is your active state and then your last state is your terminate state. Okay, whenever if you initiate any transaction, first it comes to your active state. In active state it will perform either read operation or write operation. Okay, after performing read or write operation, consider the transaction is read of A and then read of B and write of A and write of B. Okay, this is one transaction. So in this, first it will execute R of A. So your R of A is your first instruction. It comes to your active state. After completing your 4 instruction, it goes to your partially committed state. Okay, in partially committed state, it executes all the transaction and the data are stored in buffer. Then it is called partially committed state. After the data are stored in the buffer, we need to update the data into the database. So that state is called committed state. If you are updated the data into the database, then it comes to your committed state. So after updating the database, here you are going to stop the transaction. That is your terminated state. This is for every successful transaction. Suppose if your transaction occurs any failure, okay, after you are partially committed, if any failure occurs, it directly come to your failed state. In failed state, what are the modification we have done in the read and write operation? We need to roll back that values. Roll back is nothing but we are going to undo the changes that we have made in the read and write operation. After performing undo, if all the updations are made, then we are going to abort the state. Okay, and then we are going to terminate the state, terminate the transaction. Okay, suppose in the initial state itself, if any failure occur, directly it come to a fail state and it will perform abort state, and then we are going to terminate the process. This is your different states of your transaction. Okay, for each and every transaction, it follows this life cycle. So these are the slides that comes explain the transaction states. Okay, next is your schedule. So your schedule is nothing but we are going to order the sequence. Your schedule is nothing but your scheduling is nothing but we are going to order. Okay, your schedule, general meaning of schedule is ordering. In DBMS, we are calling transaction is your schedule. Consider read of A and then read of B and then write of A and write of B. This is your transaction. Here each and every line is your operations. Operations is nothing but instructions. Okay, here if a single transaction is executed in the system, then there is no problem, no need to schedule the process, because after completing the first operation, the second operation will execute, after completing the second, the third will execute, and then after completing the third operation, the fourth will be executed. This is if it dealing with only one transaction. Suppose we are going to deal with multiple transactions, then we need to go for scheduling concept. So with the help of scheduling, we are going to order the sequence, okay, in which they are going to execute. Okay, this is your main important concept in your scheduling. Why we are scheduling means to maintain the consistency in the system. To maintain the consistency, we are going to schedule the process, schedule the transaction. So next is types of schedule. In schedule is divided into two types. One is serial schedule, another one is non-serial schedule. And then your non-serial schedule is again divided into two types. That is serializable, non-serializable. Your serializable schedule is divided into two types. One is conflict and view conflict. Okay, here today I am going to focus on this serializable. Okay, I am going to focus on non-serial schedules. So first is a serial schedule. This is your types of your schedule. So first is serial schedule and the next type is non-serial schedule. So serial schedule is nothing but your serial schedule is nothing but here we are going to execute the transaction in serial order. Okay, here we are going to execute the transaction serially one after the another. Consider we are having three transactions T1, T2 and T3. Okay, if all the operations in T1 is executed and it completed, then it will move to the transaction 2. Okay, after all the operations are performed in the transaction 2, it will move to transaction 3. So this is your serial execution. If one transaction is in process, no other transaction should not start the execution. So this is your serial instruction. So your transaction is executed completely before starting the execution of another transaction. So it is also called as a non-interleaved execution. And then next come to your non-serial schedule. In non-serial schedule, here we are going to focus on multiple transactions. So here multiple transactions execute concurrently. Here we are going to execute each and every transaction in a mixed manner. Okay, consider in T1 I am having 4 transactions, that is read of A and then write of A. Okay, and then again read of B and then write of B. Likewise in transaction 2 we are having a read of A and then a write of B. So write of B. Consider this is your transaction. Okay, in non-serial schedule, first it will execute the first two. Consider it will execute first two transactions, first two operations. After executing the first two transactions, the operating system will move to transaction 2 and execute your next two transactions. Okay, after finishing your transaction 2, again it come back to your transaction 1 and execute the remaining 2 statements in the transaction. This is your non-serial schedule. So here non-serial schedule, the instructions are executed in concurrent manner. Okay, so why we are using this concurrency means to maintain the consistency. We are going to use non-serial schedule. So next is examples of your schedule. Here they have given 2 schedules. Here first, this is our first schedule, and then here this is our first schedule and this is our second schedule, schedule 1 and schedule 2. Okay, in schedule 1 we are having totally 6 operations, that is R1 of A, W1 of A, R2 of A, W2 of A, R1 of B and W1 of B. Totally we are having 6 operations, and then in schedule 2 also we are having 6 operations. Now we are going to call R1 of A is nothing but we are going to perform a read operation on data A in transaction 1. That is the meaning. Here, now come to this W2 of A. Here, this is your write operation. We are going to perform on data A in transaction 2. Okay, likewise, your R1 of B, we call it as a read operation performed on data B in transaction 1. Okay, now this representation is very difficult to understand, so I am going to modify this representation into table format. Here in schedule 1, total number of transaction involved is T1 and T2. Totally we have using 2 transactions. So I have divided into 2 columns. Based upon the transaction only, we need to divide the columns. Here I am using 2 transactions. So T1 and T2 is here 2 transactions. And then first instruction in the first schedule is R1 of A. R1 of A is nothing but read operation we are going to performing on data A in transaction 1. So in transaction 1, I need to write R of A. R of A is nothing but read of data A. Okay, and the next is W1 of A. W1 of A is nothing but write operation on data A in transaction 1. Okay, your next operation is R2 of A. Your R2 of A is nothing but read of A in transaction 2. And the next operation is W2 of A. So W2 of A is nothing but write operation on data A in transaction 2. And then next is R1 of B. So your R1 of B is nothing but read operation on data B in transaction 1. Likewise, we need to plot schedule 1 and schedule 2 as it is. Okay, here now comes your serial schedule. This is your example for your serial schedule. I already explained what is serial schedule. Here in serial schedule, after completing the transaction 1, then only your transaction 2 will start executing. Here this is your transaction 1. Your transaction 1 contains 4 different operations. After executing all this operation, then only the operating system will move to second transaction and it will execute the operations in transaction 2. This is your serial schedule. So here the operating system first will execute all the transaction in the T1 and then it will move to T2. So always your serial schedule is in consistent manner. Okay, always it is consistent. Now come to our non-serial schedule. In non-serial schedule, here first in transaction 1, the first two operations are executed. After executing first 2 operations, the operating system will move to transaction 2 and execute the first 2 statement in the transaction 2. After completing this 2 operations, again your operating system will move to transaction 1 and execute the remaining 2 operations in your transaction 1. This is your non-serial schedule example. Here the executions are concurrent each other. Okay, so here there is there may be lead to inconsistency. Okay, so we need to maintain the consistency with the help of serializability. So when we are moving to serializable concept. So next is serializability. So here serializability in database is nothing but serializability is a concept that helps to identify which non-serial schedule is correct, and we are going to maintain the consistency in the database. Okay, here serializability is a concept which helps to identify which non-serial schedules are correct and will maintain the consistency of the database. This is the main use of your serializable concept, because in non-serial schedule it may leads to inconsistent of database. In the previous example I explained, the non-serial schedule there may be a inconsistency in the database. So when we are using serializable concept, in this serializable concept we are going to identify which non-serial schedule is correct and it will maintain the consistency. How we are going to identify means, with the help of serializable schedule we are going to identify which non-serial schedule is correct. Okay, here if the non-serial schedule is said to be a serializable schedule only when it is equivalent to serial schedule for an n number of transactions. Since concurrency is allowed in this case, thus multiple transactions can execute concurrently. So next is difference between serial schedule and serializable schedule. Okay, so first is in serial schedule, okay, first is in serial schedule all the transactions are executed serially one after the another. So there is no concurrency is allowed in serial schedule. In serializable schedule, here the concurrency is allowed because multiple transactions we are going to execute concurrently. So this is the main use of we are going to convert the non-serial schedule into serial schedule. Okay, why we are converting means, in serial schedule the resource utilization and the CPU throughput is very less, but in serializable schedule it improves your resource utilization and CPU throughput. Okay, and then in your serial schedule the efficient is very less efficient when compared to your serializable schedule. It is more efficient than the serializable schedule. So next is types of serializability. In serializability we are having two types. One is conflict serializable, another one is view serializable. Okay, first see what is conflict serializable. So a conflict serializable is nothing but it is a process of finding that a given schedule is conflict serializable or not. If a given non-serial schedule can be converted into serial schedule by swapping its non-conflicting operation, then it is called as conflict serializable schedule. Okay, now see what is conflict serializable. So here we are going to find a given schedule is conflict serializable or not. So how we are going to find the given schedule is conflict or not? Here we are going to swap the non-conflicting operation, then we are going to tell it is a conflict serializable. Okay, for that you should know what is conflicting operation. Okay, your conflicting operation means it should follow these three conditions. If your two operations are said to be conflicting operation, if it can satisfy all the three conditions. Your first operation is both the operations belonging to different transaction and both the operations are on same data item. At least any one of the operation is a write operation. So this is your three conditions. With the help of these conditions we are going to identify conflicting operation. Okay, and then we are going to identify non-conflicting operation and we are going to swap to convert serial schedule into non-serial schedule. Okay, let's see example for this. Okay, this is your example for non-conflict serializable. Okay, Okay, here the T1 is your transaction 1 and T2 is your transaction 2. In transaction 1, we are having 3 instructions. The first, it will execute first 2 instruction, and then the operating system will give control to the transaction 2. So definitely this is a non-serial schedule example. Okay, our aim is to convert the non-serial schedule into serial schedule by swapping its non-conflicting operation. So here definitely we find out this is a non-serial schedule. Okay, now we are going to find the conflicting operations in this. Okay, to find conflicting operation, we are having 3 conditions. Your first condition is the 2 different operations performed on different transaction, and the 2 operations are on same data, and definitely at least one write operation should be present. These are your 3 conditions to identify your conflict operation. Here consider in this example R of A and W of A is your conflicting operation, because here both belongs to different transaction T1 and T2. So condition 1 is satisfied, and the next is it will deals with same data. Here the data is A and here also your data is A, so both are involved in same data, so your condition is true, and then any one of the operation is your right operation. At least any one is right. Here this is your right operation, so it satisfies your third condition also. So here R of A and W of A is your conflicting operations. So definitely this schedule is not a conflicting serializable. Okay. So next we will see example for conflict serializable. So conflict serializable means we are going to convert non-serial schedule into serial schedule by swapping its operation, by swapping its non-conflicting operations. Okay, so by here we are going to swap your non-conflicting operations. Let's see this example. Here first we need to identify whether the given schedule is serial or non-serial. Okay, here after executing the first 2 instructions, the program control is transferred to T1. So definitely this is your example for your non-serial schedule. Okay, so now we are going to identify the conflicting operation. So in this, your conflicting operation is, I already told about the 3 conditions. Your first condition is deals with different transaction and operating on same data, and definitely there is at least one write. Okay, this is your condition. And now check this. Here a conflicting operation is nothing but here R of A and W of B is your non-conflicting operations. How I am telling is here both are performing data. Okay, here first we need to identify the non-conflicting operation. Here R of A and W of B here are performing operation on 2 different data, that is A and B, and both is read and write. So here this is your non-conflicting operation. After finding non-conflicting operation, we need to swap this. We need to swap the operations. So in the third cycle, I am going to swap the W of A to the previous cycle and W of R of A to the next cycle. Here I have swapped this operations. So here after executing the first 2 instruction in T2, W of B will be executed. Okay, here this is considered to serial schedule. All the transaction in T2 will executed and T1 will execute. So now we have converted the non-serial schedule into serial schedule by swapping the non-conflicting operations. So this is your conflict serializable. So next we are going to Next we are going to find the conflict serializable for a detailed problem. Okay, here we are going to check whether the given non-serial schedule is conflict serializable or not. These are the steps we are going to use to find the conflict serializable. Your first step is, first we are going to find all the conflicting operation. After finding all the conflicting operation, we are going to create a precedency graph by drawing one node for each transaction. After finding a precedency graph, we need to draw an edge for each conflicting operation. Okay, if any cycle formed, then the schedule is conflict serializable. If it is not a conflict serializable, if there is no cycle, then we are going to call that schedule is a conflict serializable. Let's see example for this. So here they have given, the question is check whether the given schedule S is conflict serializable or not. Here S is a schedule contains 7 instructions. So first we need to convert the given schedule into tabular form. So here the total number of transactions involved in this schedule is 1, 2 and then 3. So we need to divide into 3 transactions. Based on the transaction only, we need to divide in the columns. So this is T1. So this is T1, this is T2 and this is T3. I have divided into 3 columns. Here first instruction is R1 of A. R1 of A comes under your transaction 1. That is, we are going to perform a read operation on transaction 1. And then next is R2 of A. This read operation we are going to perform in transaction 2. And then next is R1 of B. R1 of B is nothing but we are going to perform read operation on data B in transaction 1. So this is your R1 of B. Okay, and then next is R2 of B. R2 of B is nothing but read operation we are going to perform in transaction B. And the next is R3 of B. R3 of B is we are going to read the data B in transaction 3. So after executing this, I am going to read the data in transaction 3. And then next instruction is W1 of A. Your W1 of A is write operation on transaction 1 on data A, and then write operation on data B in transaction 2, that is W2 of B. Okay, now I have converted the given schedule into tabular form. Now I am going to find the conflicting operation. That is our first step. To find conflicting operation, so first I am going to check for the first data. Your first instruction is R1 of A. I am going to compare with remaining two transactions. You already know the condition is to find conflicting operation. It performs with 3 conditions, that is different transaction, same data, definitely one is a write operation. This is your condition. Okay, remember this while calculating your conflicting operations. So your first instruction is R1 of A. Now I am going to compare R1 of A to the next transaction. Here in the next cycle R2 of A will be executed. So now I am going to compare. Here both are involved on same data, different transaction, but both belongs to read operation. So the condition is false. So I am going to compare the next value. So the next operation is R1 of B. It belongs to same transaction, so no need to check this R1 of B. Directly go to R2 of B in the transaction 2. In transaction 2, R2 of B, here both are involved in 2 different transactions. So 2 different transactions means there is no conflict. So next check for the next instruction. So your next instruction is R3 of B. Your R3 of B deals with 2 different data items. Then there is no conflict. Then comes to your next instruction. Here this belongs to same data. So definitely there is no conflict. And then next is I am going to compare with the next value R1 of A, W2 of B. Here both are dealing on different data, so there is no conflict. For R1 of A, there is no conflict. Next, I am going to check the next value, next instruction, that is R2 of B. After executing this, in the next cycle, it will execute R2 of B. So, I am going to check for R2 of A. So, here R2 of A, I need to check with the remaining transaction. So, R2 of A, I am going to compare with R1 of B. Here, both are performed on different data, so there is no conflict. So in next cycle, I am going to compare with R3 of B. In R3 of B, both are dealing with two different data, so there is no conflict. Next, I am going to check with R2 of A. I am going to compare with W1 of A. Here first condition is, it satisfies the first condition, it involves in two different transactions, and then both are performing operations on same data, and definitely there is a one write. So this is our conflicting operation. So R2 of A comma W1 of A is your first conflicting operation for this given problem. Okay, here R2 of A and W1 of A is represents the transaction T2 followed by T1. That means after completing transaction T2, then only the transaction 1 for the particular operation will be executed. That is the meaning. Okay, now check the remaining conflict operation. So now here I have checked this. Next I am going to check the next operation. Here next operation is in the same transaction, so no need to check for this. Okay, and then I am going to check for next data. Your next data is R1 of B. This is your R1 of B. So I am going to compare with the remaining transactions. So R1 of B is, I am going to compare with R2 of B. Here both are read operation, so definitely there is a no conflict. And then next I am going to compare with R3 of B. Here both are read operation, so definitely there is a no conflict. And then here it belongs to same date transaction, so I am not going to compare this. I am going to compare with W2 of B. Here W2 of B is nothing but, here it will occur a conflict operation because it performed on same data in different transaction. Here there is a read operation, here there is a write operation. So definitely there is a conflict. So R1 of B and W2 of B, there is a conflict. That implies after executing the particular operation in transaction 1, then only the W2 of B in the transaction 2 will be executed. Okay, next I am going to check for next operation in transaction 2. So here I am going to check for R2 of B. So R2 of B I am going to compare with the next transaction. So here both are read operation, so there is no conflict. So compare with the next operation. Here both deals on different data, so definitely there is no conflict. So there is that's all. There is no other operation for this R2 of B. So next I need to compare for next operation. Your next operation is R3 of B. So here R3 of B I am going to compare with the next value, that is W1 of A. Here both are involved on different data, so there is no conflict. And next I am going to compare with R3 of B and W2 of B. Here they involved on different transaction and the data items is same. Both are involved operation on B. Here one is a write operation, so definitely there is a conflict. So R3 of B having a conflict with W2 of B. So R3 of B definitely having a conflict with W2 of B. That implies T3, after completing T3, then only we can able to complete the T2 operations. Okay, that's all. Now we have checked for the R3 of B. Next I need to check for W1 of A. For W1 of A, the next instruction in the cycle is W2 of B. Here both are dealing on different data items, so definitely there is no conflict. So that's all. We have checked for all the operations in the schedule. Okay, now these three instructions is your conflicting operation. Now we have find out the conflicting operation. Next step is we need to make a note for each and every transaction. Here the total number of transaction is 3, so I need to make a note for each and every transaction, that is T1, T2 and T3, and I need to make a edge between this. So T2 implies T1. Okay, after completing T2, then only here T1 will be executed, and then T1 implies T2. So after completing this T1, then only your T2 will be executed, and then T3 of arrow T2. So after completing T3, then only your T2 will be executed. So this is your precedency graph for this example. Here we need to check either any cycle is formed. So here T2 to T1 and T1 to T2, there is a cycle. So this is a non-conflicting operation. So this is a non-conflict serializable. If there is no cycle, then that is called a conflict serializable. So here this is the precedency graph I explained already. Here there exists a cycle. So schedule is not a conflict serializable. So next is view serializability. Your view serializability is a process of finding that a given schedule is view serializable or not. Okay, if a given schedule is found to be view equivalent to some serial schedule, then it is called a view serializable schedule. For this view serializability, we are having three conditions. First is initial read, final write, and then update read. Here for two schedules, we are going to check this three conditions. Let's see the example. So this is your example for your view serializability. So first I'm going to check the first condition, that is initial read. So first I am going to check the first condition, that is initial read. Initial read is nothing but we need to check for two data item X and Y. Okay, totally here the data item involved in this schedule is X and Y. We need to check for X and Y whether the initial read is done by T1, then obviously the schedule 2 is also the initial read should done by T1. Suppose if the initial read for Y is done by T2, then obviously the schedule for schedule 2, the initial read is done by T2. Okay, likewise we need to check the initial read. So first here in schedule 1, R of X is your initial read condition for data item X. Okay, initially it is done by T1. Likewise, now come check in schedule 2. In schedule 2, your R of X is your reading of X element is done by transaction T1. So it is satisfied for X. Okay. So here in schedule 1 and schedule 2, both are involved on X data by transaction 1 and transaction 2. In transaction 1. And next check for Y. So in Y, here the initial read is done by transaction 1 in schedule 1. Likewise in schedule 2 also your first read operation on Y is done by transaction 1. So here both the conditions are true. So obviously the initial read condition is satisfied. So next is second condition. So next is view serializable for condition 2, that is final write. So in final write, we need to check the final updated value of X and Y. Okay, let's check for X. In schedule S1, the final write operation on X is done by transaction T2. In schedule S2 also, the transaction T2 will perform the final write operation on X. So here both the write operation will be performed on transaction T2. Okay, now check for data Y. Okay, now check for Y. In schedule S1, the final write operation on Y is done by transaction T2. Sorry, this is not. Here the final write operation is done by transaction T2. Likewise in schedule 2, the final write operation is also done by transaction 2. So here both are equal. So the final write condition is satisfied for schedule S1 and S2. Next see for the third condition. So your third condition is update read. So your update read, we are going to check whether the updated value of X and Y is read by particular transaction that is written by the previous transaction. Okay, now check for X. Okay, now check for x. In schedule S1, T2 reads the value of x that is written by T1 transaction. Likewise, in schedule 2, the same transaction T2 reads the value of x that is written by transaction T1. Okay, now both satisfied. Now check for y. Okay, now check for y in schedule 1. In schedule 1, T2 reads the value that is written by T1. Okay, likewise for in schedule 2, the T2 reads the value that is written by transaction 1. So here both are satisfied. So your update read condition is also satisfied for both the schedules. So since all the three conditions that checks whether the two schedules are view equivalent are satisfied in this example, so which means S1 and S2 are view equivalent, and also we know that the schedule S2 is the serial schedule of S1, thus we can say that the schedule S1 is view serializable schedule. Okay, next we'll see gate problems. So this is our first question. This is asked in GATE CS 2010, question number 42. Your question is, consider the following schedule for transaction T1, for the transaction T1, T2 and T3. Okay, here this is your question. Here they have given directly, they have given in tabular form. So no need to convert the given schedule into tabular form. So here totally the transaction involved in this is 3 transactions performing data on X and Y. Okay, here we are going to find which one of the schedule below is the correct serializable. We need to find which schedule is correct. Okay, for that we need to list all the conflicting operation, and then we are going to draw a precedency graph. If there is any cycle form, then there is, if any cycle form that is not serializable. If there is no cycle, that is a serializable. Okay, let's solve the problem. Okay. Here this is a question given. So here the transaction is T1, T2, T3. This is the question. So first initially we are going to read the X. Okay, so in transaction 1, your first operation is read of X. So read of X, I need to find the conflicting operation. So for read of X, I am going to compare with the next transaction, that is read of Y. Here read of Y, here there is no conflict because both are read operation. So definitely there is no conflict. So next I am going to compare with read of Y. So read of Y, here also both are read operation performing on different data. So definitely there is no conflict. So next I am going to check the next value, that is write of Y. I am going to compare with read of X and write of Y. So your read of X and write of Y both are performing on different data. So definitely there is no conflict. So next I am going to compare with next value. This belongs to same transaction. So no need to check for the conflicting operation. So next is, your next instruction is write of X. Now I am going to compare read of X with write of X. Here your first condition is it belonging to different transaction performing operation on same data. Yes, it is satisfied. Any one is a write operation. Yes, definitely there is a one is a write operation. So this is a conflicting operation. Okay. Now I am going to write it in conflicting operation. That is R1. Read of X is nothing but performing reading operation on data X in transaction 1. So that is read operation on data X in transaction 1. So R1 of X, and this is your conflicting operation, that is write operation on data X in transaction 3. So that is W3 of X. Okay, here after completing transaction 1 only, your transaction 3 will be executed. This is our first conflicting operation. So and then after checking this, I need to check for next operation, that is read of X. So read of X I am going to compare with the conflicting operation. Here there is no conflict. So next compare with the next operation. Here both are performing on same data. Here one is a write operation. Definitely there is a conflict. So I need to update in the conflict conflicting operation. So that is R1 of x. That is R1 of x, and this is your write operation on x in transaction 2. So W2 of x. So here after executing T1, your T2 will be executed. So this is our second conflicting operation. So next I am going to check for read of y. So read of y, I am going to compare with the next operation. Here both are involved in read operation, so there is no conflict. So next I am going to compare with write of x. Here both are performing on different data, so definitely there is no conflict. And then in the next cycle I am going to check with write of x. Here both are performing on different data, definitely there is no conflict. And here this belongs to same transaction, no need to check for conflicting operation. So your next in the next instruction is a read of y. So you read of y, I am going to compare with the next transaction 2. So in transaction 2, read of y is compared with write of y. So here both are performing operations on same data. Here one is a write operation, definitely there is a conflict. So R3 of y comma W2 of y is your conflicting operation. So after completing T3, then only your T2 will be executed. So next I am going to compare read of y with write of x. Here both are performing operation on different data, so definitely there is no conflict. And the next is this belongs to same transaction, no need to check for conflicting operation. So next I am going to check with next data, next operation. Here both is a read operation, there is no conflict. Next is both are performing operation on different data, so definitely there is no conflict. Now I have checked for read of y. Next cycle I need to check write of y. So in write of y I need to compare with the remaining elements, remaining operations. So write of y I am going to compare with write of x. Here both are performing operations on different data, so there is no conflict. Here next I am going to compare with the next operation in transaction T3. So W of y is compared with W of x. Here both are performing on operation on different data, so definitely there is no conflict. Here remaining belongs to same transaction, so no need to check for this. And the next is I am going to check for write of x. So write of x I am going to compare with the next instruction is write of x. Okay, here both performing write operation on same data, definitely there is a conflict. I need to update in my conflicting operation. So here this write operation belongs to transaction 1 and this write operation will belong to transaction 3. So W1 of x comma and then W3 of x. After completing transaction 1, then only a transaction 3 will be executed. Okay, next is I need to check for write of x. So your write of x is I need to compare with the read of x. Here both are belonging to same data but performs write operation in this, so definitely there is a conflict. I need to update in my table. This is your this is your write operation on. So this is your write operation on W3 and this is your R2. So W3 of x comma R2. Okay, before this I need to check for the remaining elements. Okay, this is W1 of x I need to compare with read of x. Here both are conflicting operation, so I need to update in my table. So W1 of x comma R2 of x is a conflicting operation. So after completing T1, then only a T2 will be executed. Likewise, check for write of x and write of y. Okay, here both are conflicting operation because performing operations on same data and both are write operation. So I need to update in my table, that is W1 of x comma W2 of x, that is T1 implies T2, and then only I need to check for write of x. Okay, write of x is compared with read of x. Here this is a conflicting operation, so W3 of x is R2 of x. It's a conflicting operation, so T3, after completing T3, then only a T2 will be executed. Okay, and then next is I'm going to compare write of x with write of x. Here both are writing operation on same data, so this is definitely a conflicting operation. So W3 of x comma W2 of x is a conflicting operation. After completing T3 only the T2 will be executed. Okay, now I have checked for all the operations. Okay, after this comes to read of y, there is no comparison for this read of x and write of x, so we are going to stop checking the conflicting operation. Now final conflicting operation is, this is my final conflicting operation. Now I am going to draw a precedency graph for this conflicting operation. Okay, now consider total number of transactions involved here is 3, so T1 and then T2 and then T3. Okay, and then we need to make an edge between T1 and T3. So T1 to T3, that is the edge, and T1 to T2, that is the edge, and then T3 to T2, that is the edge, and then T1 to T3, there is a edge. We already drawn an edge, and then T1 to T2, already there is an edge, and then T1 to T2, already we have drawn an edge, and the next is T3 to T2, already there is an edge, so no need to draw, and then again T3 to T2, already we have drawn an edge. Okay, now we have formed a precedency graph for this schedule. Now we need to find the order of sequence of transaction. Here, to find the order, here for this T1 there is no incoming edges, so definitely this is your first transaction, definitely this is your starting transaction T1, and then for T2 there is no outgoing edge, so definitely this is your last transaction, that is T2. Okay, obviously there is only one transaction that is performed in between T1 and T2, that is T3. So first it will execute T1 transaction and then T3 and then T2. So this is our answer. Now check your answer. So T1, T3 and T2, this is your consistent, this is your serializable. So your option A is your correct answer. So nextly, let's see the second example. This is asked in GATE CSE 2022. This is your 2-mark question. Your question is, let Ri of Z and Wi of Z denote read and write operation on a data element Z by a transaction Ti respectively. Consider the schedule with 4 transactions. Okay, here in this schedule they have given 4 transactions and the number of operation is 1, 2, 3, 4, 5, 6, 7, 8. Total number of operation in this schedule is 8. The transaction involved here is 4. Now we need to find whether the given schedule is conflict equivalent or not. Okay, we need to find the given schedule. Okay. So here this is our question given in So this is our schedule that is given in the question. Okay, now I am going to convert this schedule into table form. Here the total number of transaction involved is 4. So I have divided into 4 columns, that is T1, T2, T3, T4. Okay, the first operation is R4 of X, that is read operation on data X in transaction 4. So first I need to update in first row. And then next is R2 of X, I need to update in transaction 2, and then R3 of X I am going to update in transaction 3, and then R1 of Y. Likewise, convert this schedule into table form. Okay, and then now we are going to find the conflicting operation. Okay, here in this schedule, in the first cycle, R4 of X will be executed. Okay, so first I am going to compare R4 of X with the remaining 3 transaction for conflicting operation. So R4 of X, this is your R4 of X. Now I am going to compare R4 of X with R2 of X. Okay, because in the next cycle R2 of X will be executed. So I am going to compare. So R4 of X, both are read operation. So definitely there is no conflict. And the next I am going to check with R3 of X. Okay, here R3 of X means here there is no conflict, because both are performing read operation. And the next I am going to compare with the next cycle. In next cycle R1 of Y, both are read operation, so definitely there is no conflict. So next, in the next cycle W1 of Y will be executed. So I am going to compare R4 of X, W1 of Y. Here both are performing on different data. Okay, then there is no conflict. Next I am going to check for R2 of Y. So R2 of y, here both are performing operations on same data. Here one is a write operation. Okay, definitely there is a conflict. That is R4 of x, comma W2 of x. This is our first conflicting operation. Here after completing transaction 4, then only your transaction 2 will be executed. Okay, this is our first conflicting operation. So next I am going to check for next W3 of y. So W3 of y is, here it will perform operations on two different data. So definitely there is no conflict, and then here it belongs to same data, so no need to check for conflicting operation. For the first operation I have checked conflicting. So next I am going to check for R2 of x. Your next instruction is here R2 of x. I am going to compare R2 of x with R3 of x. Here both are read operation, so there is no conflict. So next I am going to compare with R1 of y. Here both are read operation, so there is no conflict. Next I am going to compare R2 of x with W1 of y. Here both are performed on different data, so there is no conflict. And then in the next cycle, here belongs to same transaction, no need to check for this instruction. And then come to T3. In T3, R2 of x is compared with W3 of y. Here there is no conflict because they perform operations on two different data. And then R2 of x is compared with R4 of y. Here there is no conflict because it perform operations on two different data items. Okay, next I am going to check for R3 of x. So I am going to compare R3 of x with R1 of y. Okay, here both are read operation on different data, so there is no conflict. And then next I am going to check for W1 of y. Here both are performing operations on different data items, so there is no conflict. Next I am going to compare with W2 of x. Here both are performing operations on same data, that is x, and one is a write operation, so definitely there is a conflict. So R3 of x, comma W2 of y, that's a conflicting operation. So after completing T3, then only a T2 will be executed. So next we'll check for R1 of y. Okay, R1 of y I am going to compare with the next cycle, so that is W2 of x. Here both are performing operations on different data items, so there is no conflict. And the next R1 of y is compared with W3 of y. Both are performing operations on same data, one is read, another one is write, definitely there is a conflict. So next conflicting operation is R1 of y and then W3 of y. So after completing transaction 1, then only your transaction 3 will be executed. Okay, so next is R1. After checking this, I need to check for next data item. So next data item is R4 of y. Here both are read, definitely there is no conflict. Next come to your next instruction, that is W1 of y. So W1 of y I am going to compare with the next instruction. Here both are performing operations on two different data, definitely there is no conflict. And then next I am going to compare with W3 of y. Here both are performing operations on same data, here both is a write operation, so definitely there is a conflict. Your next instruction is W1 of y and W3 of y, that is after executing T1, then only your T3 will be executed. Okay, now check for the next operation, W1 of y and R of y. And R of y. Here both are performing operations on same data, that is y, and this is a read operation, this is a write operation, definitely there is a conflict. So W1 of y, comma R4 of y. So after completing the particular operation in T1, then only a T4 will be executed. So next instruction is, here I have checked for W1, so next I need to check for W2 of x. Okay, I am going to compare W2 of x with the remaining transaction. So here W2 of x is compared with W3 of y. Both are performing operations on different data, so definitely there is no conflict. So I am going to compare W2 of x with R4 of y. Both are performing on different data items, so definitely there is no conflict. So next come to this next operation, this is W3 of y. So W3 of y I am going to compare with R4 of y. Both are performing operations on same data, that is y. Here one is a read operation, another one is a write operation, so definitely there is a conflict. So your next operation is W3 of y, comma R4 of y. That means after executing T3, then only your T4 will be executed. Okay, now we have listed out all the conflicting operation. Next we need to draw a precedency graph for this. Okay, your precedency graph, to draw precedency graph, total number of transaction here is 4. So T1, T2 and then T3, next is T4. This is your total number of transaction. So first transaction, there is a edge between T4 to T2. So we need to draw, this is T3. Okay, we need to draw edge between T4 to T2. So next edge is T3 to T2. So from T3 to T2 there is an edge, and then from T1 to T3 there is an edge. T1 to T3 there is an edge, and then from T1 to T3 there is an edge. Already we have drawn that edge, and then T1 to T4 there is an edge, and then next is T3 to T4 there is an edge. Okay, now we are going to check whether there is any cycle or not. Okay, so your path is T1, T4. After reaching T4, there is no way to reach T3. So definitely there is no path for this graph. Okay, so for next find out the starting node. Your starting node is T1 because there is no incoming edge for T1. And then your ending node, there is no outgoing edge for, there is no outgoing edge. So there is no incoming edge is your ending node. So your ending node is T2 because there is no outgoing edge. For incoming edge, you need to check there is no incoming. For your first node, we need to check there is no incoming edge, and then for the last node we need to check whether there is no outgoing edge. So your starting node is T1 and your ending node is T2. Okay, for this we need to find a path. Okay, in between you need to execute T4 and T3. For that you need to find a path. Starting node is T1. From T1 to T4 there is a path. After executing T4, there is no way to reach T3. So this is not a correct path. So go for next direction. From T1 there is another edge. So from T1 to T3 there is an edge. After executing T3 there is a path to reach T4. So after executing T4 we can able to move to T2. So this is our correct path. So the first instruction is T1, and then we are going to execute T3, then we are going to execute T4, then only at last your T2 will be executed. This is your sequence: T1, T3, T4, T2. Now let's take our answer. So this is your precedency graph, and your answer is T1, T3, T4 and T2. So this is your option A. Sorry. So next is your third question in your GATE CSE 2021. This asked in set 1. This is a question, 2-mark question. Let Ri of Z and Wi of Z denote read and write operation respectively on a data item Z by a transaction Ti. Consider the following two schedules. Here they have given two different schedules, that is S1 and S2. So in S1 they have given 6 different operations. In S2 also they have given 6 different operations. Now our aim is to find out whether which of the following option is correct or not. We need to find whether the given schedule is conflict serializable and S2 is not a conflict serializable, or S1 is not conflict serializable and S2 is a conflict serializable. Either both S1 and S2 are conflict serializable, or neither S1 nor S2 is a conflict serializable. So for that we need to find the conflicting operation, and we are going to draw a precedency graph for this, and then if there is any cycle, that is a non-conflicting serializable. If there is a cycle, if there is no cycle, that is a conflict serializable. Here this is the question given. First is S1 is your first schedule, S2 is your second schedule. So for easy understanding, I have converted the given schedule into two tabular forms. Okay, first schedule deals with two transactions, that is T1 and T2. So your first schedule deals with transaction 1 and transaction 2. Okay, I have plotted the schedule as it is. Okay, initially in second schedule also it deals with two transactions, that is T1 and T2, and then I have plotted the values in the table. Okay, here R1 of X is nothing but read operation performed on data X in transaction 1. Okay, that is similar. Okay, now we are going to find the conflicting operation for this. So first I am going to find conflicting operation for S1. Okay, and then I'm going to find a conflicting operation for S2, and then I'm going to tell whether it is if there is any cycle formed in this, then it is not conflict serializable. If there is no cycle, we are going to tell it is a conflict serializable. Okay, so first check the conflicting operation R1 of X. This is our first instruction. So I'm going to compare with the second transaction. So here R1 of X is compared with R2 of X. Both are read operation, so definitely there is no conflict. So next I'm going to compare with the next instruction, that is R2 of Y. Here both are performed on two different data items, so definitely there is no conflict. So next is here also both are performed on two different data items, so definitely there is no conflict. So for first instruction there is no conflict. So next I am going to check for R1 of Y. So I am going to compare with the transaction 2. R1 of Y is compared with R2 of Y. Here both are performing operations on two different data. Definitely there is no conflict. Here also performing on same data, but both is a read operation, so definitely there is no conflict. And then next is here both are performing operations on same data, but here it will perform write operation and here it is a read operation, so definitely there is a conflict. So your first operation is R1 of Y comma W2 of Y is your first conflicting operation. That means the particular operation in transaction 1 is executed first, then only the particular operation in transaction 2 will executed. So this is our first conflicting operation. So after checking this, next I need to check for R2 of X. So I am going to compare R2 of X with W1 of X, because in transaction T1 the next instruction in the next cycle is W1 of X. So I need to compare with this only. Don't need to compare with the already checked operations. Okay, so R2 of X is compared with W1 of Y. Here both are performing operations on same data. Here this is a read and this is a write operation. Definitely there is a conflict. So R2 of X is comma W1 of X. So after completing T2, then only a T1 will be executed. Next check for next data, that is R2 of Y. Here both are performing operations on different data, so definitely there is no conflict. Here next check for next data. Here both are performing operations on different data, so there is no conflict. Next come to your transaction T1. Here there is no other operations to compare, so we are going to stop calculating your conflicting operation. Now in this schedule totally we are having only two conflicting operations. Okay, now we are going to draw a precedency graph for this. The total transaction involved in this schedule is two transactions, that is T1 and T2. So from T1 to T2 there is an edge, from T2 to T1 there is an edge. So here it forms a cycle. So it forms a cycle means S1 is not a conflict serializable. Okay, so next we are going to check for schedule 2. In schedule 2, total number of transactions is T1 and T2. Totally we are having two transactions. So first I am going to check for conflicting operation for R1 of X. So R1 of X is compared with R2 of X. Here both are involved on same data, but both are read operation, so definitely there is no conflict. So next I am going to compare with next two data items. Here R1 of X is compared with R2 of Y. Here both are performing operations on different data, so definitely there is no conflict. And then R1 of X is compared with W2 of Y. Both are performing operations on different data, so definitely there is no conflict. So we have checked for first instruction, and then next I am going to check for second instruction, that is R2 of X. I am going to compare R2 of X with R1 of Y. Here both are performing operations on two different data items. Definitely there is no conflict. And then R2 of X is compared with W1 of X. Here both are performing operations on same data. Here this is a read operation, this is a write operation. Definitely there is a conflict. So this is our conflicting operation, R2 of x comma W1 of x. Here after completing T2, then only a T1 will be executed. Okay. Next I am going to check for R2 of y. So here R2 of y is compared with R1 of y. Both are read operation. There is no conflict. So here R2 of y is compared with W2 of y. Here both are performing operations on two different data. So definitely there is no conflict. And then next is W2 of y. So W2 of y is compared with R1 of y. Here both are performing operations on same data. Here there is a read and there is a write operation. Definitely there is a conflict. So your next in conflicting operation is W2 of y comma R1 of y. So after completing T2, then only a T1 will be executed. Okay. Next I am going to check for next data. This is R1 of y. There is no other operations to compare for these two values. So we are going to stop finding the conflicting operation. Now we are going to draw a precedency graph. Okay, your precedency graph for this is total number of transactions T1 and then T2. So T2 to T1 there is an edge, and then T2 to T1 there is an edge. Already we have drawn an edge. So there is no other conflicting operation. So there is no cycle for this schedule. So obviously your S2 is your conflicting operation. S1 is not conflict serializable. So your option B is your correct answer. So that's all. Thank you.